Tonight on Rubber Duck Engineering, we are going to build a Lisp interpreter from scratch.
From scratch?
From scratch. We'll see how far we get.
So I haven't even shown the banner yet, but I don't know Lisp. and I have no idea how to build a Lisp interpreter, but this will be fun.
We're gonna try to like summon the spirit animal of Lisp. It's not gonna be common Lisp. It's not gonna be any actual fancy. It's just gonna be a very basic Lisp.
It's gonna be Rubber Duck Lisp.
Rubber Duck Lisp. Excellent.
That should have totally been the title of the repository. Which, by the way, if folks want to follow along, we're on GitHub. Hi, Adam. Nice to see you.
Good to see you. How are you, Eric?
I'm really quite good. Quite good. I was on vacation all last week. It was glorious. And now I'm back at work, and it's a good day. So
cool.
Shall we get to the code machine so we can
the code machine.
At least get can. Is it can or car?
Car and Cooter? We'll get car and Cooter. Maybe.
All right.
I think I'll settle for like parsing an S expression. I think that would be a good goal for this episode. Parse the S expression and print it back out. Like I think that's a place to start.
Okay, we have a code machine.
Okay.
So this is just an empty Rust project, which, by the way, can I just say how really, really good Rust is? In particular, the Rust up. The tool chain management in Rust is really exceptional, better than any language I've dealt with.
Yeah, we had a minor crisis before the show where like there were just errors spewing everywhere.
Yeah,
and it was because Eric had a like version of Rust on his computer from like 2021 or something. And
I had a nightly build from last year because I needed it for the fuzzing episode that we did, and that was like the last time we touched Rust.
Anyway, then he typed like a couple lines on the command line, and boop, Bob's your uncle. He's on the latest stable, and everything was good.
So this is just the Rusty line example because we didn't need to go through how to like read from a terminal.
Yeah, Rusty line is a package like readline, if you're familiar with readline, where it reads in a line of text from the terminal and then handles things like editing and history, and you can even put in like an autocompleter and like all kinds of fanciness.
And so if we pull up the terminal, we just do cargo run. It just dumps us into like a REPL loop, right?
Yeah, so I think if you type something, hit return, it'll print it back out for you.
So it's basically already done the episode for us. We're good.
We're good. It's got the read and print. It's just the eval step in the read eval print loop that's missing.
See, if we had outro music, I could play the outro music now.
This is when you do what is it? Agile development. You put up like read, eval, and print as your 3 stories, and give them like 1 story point for read and print, and like 1,000 story points for eval.
Okay. Okay, so now we got to add eval.
So first we need to parse like S expression.
Can you? So what is an S? The poor reader and me, since I have no idea what I'm doing. What the hell is an S expression?
Okay, S expression is like the basic structure inside of Lisp. So Lisp loves parentheses. So the way Lisp works is you have a left parenthesis, then you have a bunch of tokens that are separated by spaces, and then you have a right parenthesis. And then inside of those things, you can have more things like that. And that basically corresponds to a tree, which is the syntax tree for your program.
So are we basically writing the like infix notation calculator here?
Yes. Well, it's infix. Lisp is prefix. So the first element of the S expression is the one that controls what's going to happen. But we're not going to we shouldn't even start there. We should start just by being able to read these things in.
So it's
Lisp or Python. Python also loves parentheses, but if you haven't seen Lisp loves parentheses. So yes.
Okay, so we have.
Yeah, we want to read in something like that.
And it's a space delimited list.
Mm-hmm. And then
there must be like, quotes and stuff like that.
Yeah, I'm sure there's lots of fancy things, but we'll just start with the basics. Okay.
So we want to read in this XYZ, and what what happens from that?
So that should create, if you scroll up on this Wikipedia page, you'll see it should create basically a binary tree structure.
Okay.
Where in the top level, the left tree is going to be X, and then the right tree is going to be another binary tree where the left one is Y, and then another one where the left one is Z, and then the right one is nil.
Okay. So it is. It literally, this is like, we're basically writing a prefix notation calculator.
Absolutely.
Oh, great. Okay. We can write a prefix notation space and calculator. This is like, we're doing our, like interview questions here.
Lisp is great for interview questions because it's very simple, and so you can like explain it all during an interview.
So like our MVP is to parse our prefix calculator, which is going to be like, we want, whoa, not that. Nope.
Not that. That's
Add Copilot.
Calculator.
Add Copilot. There we go. Plus, there you go.
Yep. And then be able to print that back out.
There you go. Oh, print that back out.
Yeah, then we'll do evaluation as a separate step. Let's just start by reading it in and printing it back out.
Oh, okay. So like we build the parse tree and then we splat the parse tree back to a string.
Yep, absolutely.
All right, not a problem. What is this?
Do you want to make your font a little bit bigger?
Oh, did I not make our
I think it's fine. I think it's
screen size correct.
Maybe it's okay.
Okay, well,
maybe it's fine. You can tell us in the comments if you'd like it bigger.
Yeah. I think this is the normal sizing that we set up, but please let us know if it's too small.
Yeah, so we're going to need like a thing called a cell.
Why? Why is it called a cell?
It's called. that's Lisp for node in this tree.
Okay,
it's
fine.
Called cell. I don't know why.
Okay, or parse node, but yes, go ahead.
So then it's cell is
instruction. Is it always left, right, or
yeah, left, which is also option box cell. Fine, and right is option box. I don't know if we want arc or box. Let's start with arc. Well, let's start with box. We may end up with arc.
Why would we want arc? Because we hold these things by reference.
The trees. Okay, so there's like pure Lisp where there's no side effects. And so I don't think you can create cyclic structures without side effects. But then there's Lisp where there are side effects where you can change the contents of one of these cells. Let's start with box. I think we'll probably be able to go a long way with box, but we may eventually need to switch to arc.
Okay.
Okay.
I mean, for this example, we don't need anything more than.
Correct. So let's start here. So we want like a new. We should probably give this a name, right?
Before you go further, this was, I think, covered in our. We have to turn this into some other form for when it has multiple args, right?
No, it's just supposed to be literally a binary tree all the time.
No, I'm just saying in order to turn into a binary tree, this is ternary, right? As we've expressed this.
Right. So why don't we draw out and ask you what the tree is going to be when we're done?
Well, and they did that in this S expression, right? The XYZ stands for X dot. What?
Yeah. So let's just do it here. So this is going to have.
I mean, to do it here, right?
Yeah, it's going to be like that. So basically, you're always dealing with these binary cells, binary tree cells. How to learn a vast amount of programming languages at the same time, one at a time. is what I would recommend. But what I would recommend actually is just learning a primary language, like picking one that you find useful. Like Python is a good starting language. I started with C. It doesn't really matter what the starting language is. And then you add a second one, and then a third one, and then after that, they're all so easy.
Yeah, I would definitely agree. One at a time. But the thing is, you don't have to get, like, programming languages have like 90 words in them. Really what you're learning, honestly, is frameworks, because the language themselves doesn't have that much concept. But once you've learned a couple, they just start to, you pattern match across them, right? Like a list, you know what a list is, but you learn what recursion is. But like, you just, don't try to learn them all at once would be my recommendation. So help me understand. I don't understand this tree.
Okay. Help me. Can you ask a question or?
Yeah. So okay, so like, what is this root node here? That's like, what does a node mean to have like for and nil?
Mm-hmm. So nil is a very important value. So nil is like a null pointer. It's like null in other language. It means no more cells down here.
Okay. So if I was evaluating this, it's like, hey, I have an operand, and then look at this tree. I want 2 plus this side of the tree. Why does this node exist?
Why does that node exist? Well, let's talk about what would happen if that node didn't exist. If that node didn't exist, this would correspond to a list with 5 items in it. So it's what's saying the third item in your list is a sublist. So it's creating the sublist. So a list is basically a chain of these cells that ends in nil.
Okay.
So just understand, like Lisp is super duper old. So the Lisp was invented for basically a machine that had this as a basic structure in its instruction set, where there was an A register and a B register.
Okay.
And so that's what car and coulter are, or I guess it was a D register. And so it's in a world where, imagine linked lists were like the most important data structure in the world. It's like the linkiest, listiest system in the world. Turns out that's wrong. Turns out the way computers evolve, like vectors and linear memory, would turn out to be the right answer. But in this alternate reality where linked lists was the right structure, they decided to make everything a linked list made out of binary trees.
So, okay, I get the pattern then that a list is just all in a row until you just keep going right until you hit nil, and then you're at the end of your list.
Oh, I'm glad you're enjoying it. Yep.
And so then a sublist is this funny structure. Anytime you have something to the left, that's like the argument that you're putting there. And anything to the right is the next pointer. So it's like, so the left pointer is actually value, and the right pointer is next.
Correct.
Okay. So
I think we actually screwed this up. Value. So we actually need enum, right? Like we need enum, which is like which is a value, right? So that could be, let's just do like string for now. The string, and then there's another. There's nil as a possible value, right? There's nil, and there's cell, which is a cell, and string, which is a string.
Is it a box cell?
A box cell, yeah, absolutely. Right.
Is it box string as well, or?
I think string is internally boxed.
I see. So we've just, this like re-implements option. We could have flattened this out as.
Well, we wanted more, right? Because we're eventually going to put integer and a few other like primitive types here.
But we're going to fight Rust by putting our option inside value.
Okay, you want to put the value outside the option outside?
I remember we had this problem in previous time when we were using Rust where we put our none value in our, like when we were doing ren, we did this.
All right, we put the thing. So this thing is going to return actual value, not option value. Okay. And in order to do this, I need a left option value and a right option value. Okay. And it's going to return this. I'm going to wrap this in the value constructor, I guess. What did I do wrong? Value cell.
I mean, if we weren't like trying to use listy names here, this would be a required argument, the first one, and the second one would be optional. Like left is always a value. Is it ever valid to have nil in the left? Maybe explicitly?
Oh yeah, you can have nil in the left, for sure. Like there's a constant called nil that you could just use to summon the value nil whenever you want.
Okay.
Okay. Is Lisp just for fun? Lisp is used in industry, I think, most commonly in Emacs. So you program Emacs in Lisp, and so people who are like super fans of Emacs like go crazy with Lisp.
Also, websites that you use were historically, they may no longer be written in Lisp. Like Reddit was in Lisp.
I think Hacker News
may still be in Lisp. I don't know if it still is.
I think it still is. I don't think.
Well, it's one of the, both of those are stories of like Steve when he started Reddit, and he was the only person programming it. That worked totally fine until until you hit enough programmers, and then you're going to teach them all Lisp, this programming language that like not everyone uses. And the same thing I think happened with Hacker News. I don't know if it's still in Lisp, but I knew it was at one point.
Cell is not a symbol, but the string is better called symbol. Yeah.
Okay.
Okay. And then I think we should have one of these, which is from vec, where we take values as a vec of function value.
I'm getting slightly ahead of ourselves, but I think some of the comment questions are sort of like, why are we doing this, or why is this interesting? My understanding is one of the big interesting things about Lisp is that code is data.
Yeah, so another way of thinking about it is Lisp is a very, it's like if you boil off all of the fancy things in programming languages, Lisp is sort of showing you what is the core of what's actually going on. And so Callie asked the question, how do you learn lots of programming languages? The way you learn them is you learn the basic core of what's going on, and then each language dresses it up a little bit differently. And so part of what Lisp is teaching you is like you literally program by just writing in the abstract syntax tree, where every language has an abstract syntax tree. It just has a lot of fancy keywords and lexical structure to hide it. But in Lisp, you just literally like type in the syntax tree.
Yep.
Yeah, there are tons of Lisp successors. And so like if you like want to understand the SAT solvers, for example, like they often have like nice Python bindings, but those Python bindings basically boil down into like this S expression like syntax for presenting the problem to the SAT solver. And JSON is also like, you can think of JSON as sort of like a modern kind of Lisp, where it's not just lists, it's vectors and maps, but it's the same idea.
We haven't, I don't think, shown it on this show, but you and I actually did a whole bunch with Z3 about 10 years ago. Maybe we'll dig up some of that code.
Z3 is like I was just going to tell the audience what Z3 was. Z3 is a SAT solver. So you give it a bunch of constraint equations, and then it will figure out, even though it's an NP hard problem, it'll figure out fairly quickly like reasonable solutions. You can like feed it like a Sudoku problem. Just tell it all the rules of Sudoku, and it will like fill out your Sudoku grid like that.
Yep. We wrote a bridge bidder in Z3. Okay, so you were adding from vec.
Yeah, I just think this is what Copilot suggested. Yeah, cell new.
Are cells editable?
In pure functional Lisp, no. If we get, depending on how far we get into this series, we may add a function that lets you modify a cell. But that's traditionally those functions end with a exclamation mark, because they're sort of like, oh, dirty, you're modifying a thing.
Okay. So why is this starting with, this is like the terminal cell?
Yeah, so I think this is not quite right. I think we want our terminal cell to be actually none. But we have to decide, like, what is the empty list? We should have like I think it should really be none. It should be none. It should be the, yeah. The type of this should be option value. And then this should be, we should just pass in the previous cell. And this should be sum. And this should be, this has to return option value. Because if you pass in an empty list, we'll give you back none. So this is, yeah. So I think we're making a choice here. So like we're deciding that and I think this is a common choice in Lisp, is that the empty list is the same as nil.
Okay. I have no idea if that's true, but that makes sense. What's with the single quote?
Sorry. That's a convention. So we're just going to right now parse the expressions. Normally, if you do that, the interpreter will evaluate them. But if you don't want the interpreter to evaluate it, you put a little quote in front of it that says, "Hey, don't actually evaluate this. Just give me this tree as a value."
Okay.
So we're sort of going to implicitly quote all of our inputs to start with. And then once we do evaluation, we'll have to learn how to do it.
All right, so this is option value is none. This is the empty list. Should we have that be a constant?
I mean, none is a constant, right?
I meant like a named, but yeah, okay, that's fine. Like we're doing a little bit weirdness. Like it depends on like how much are we following Lisp, or how much are we following Rust? And we made this concession to following Rust by like using the sum type rather than using it in our own value, based on my hunch that we'll want to get there just based on our experience with Ren.
Correct. So if we put this in the enum, this would have been value : nil. I think is what you're saying.
Yeah. And anyways. And you could imagine wanting to write, I'm going to forget my, this would be option.
Yeah, it's interesting. So Copilot is telling us that we're doing this wrong, that the empty list should be none. So we may find out that Copilot is right, but I think we should try to head down this path and see.
Why is it complaining about these?
Because they're not used.
Oh, it's not used. Okay, fine.
That's fine. Yeah.
Okay.
Okay.
Anyways, this could then be.
Yeah, so I think that's quite nice, actually. I think we can say self. Okay, so I think we have our data structures. So now we got to write our parser.
What is from vec for? I see, because
it'll just be convenient for our parser because we're going to parse it in the form where it has an arbitrary number of the way you've written it, right?
Okay, great.
So let's write our parser. So we're going to write parse. Okay, this is what Copilot thinks the answer is. It feels like cheating to have Copilot. Like Copilot knows about this stuff.
Well, it just changes. We've talked about this before, but it changes your job to reviewing rather than.
Okay.
Okay.
Result
White space.
Okay. Make a new vector for each token. Okay. If the token is a left parenthesis, sub values is a new vector.
Yeah.
Okay. There's something, this can't be right because we need a stack. We either need recursion or we need a stack. So maybe values is going to be our stack. Let's see. Oh yeah, okay. Some token, get the next token. If it's there, break, which means we're done. Otherwise, recurse. Yeah. Push this onto here. Yeah. Otherwise, push self from vec the sub values. Okay. And then if we get a mismatched parentheses, no good. Otherwise, anything else, we want to take the token into a string and it's a symbol. Yeah, this is like exactly, seems right.
Yeah, it seems fine. I don't think you're going to end up wanting this to recurse. Like you're going to want this to be, use tail recursion and turn it into an iterative loop. But
let's put it to do like convert to use a stack rather than using the runtime stack. Do you want to explain why? Like I agree with you, but just for the audience.
Well, just like why limit yourself to like, first of all, the stack is just super heavy weight relative to what you're doing. But also then like why limit yourself to the stack depth? Like why have your language affect your like inner language in that way? As opposed to some, we have this again problem in Ren because I think we did this as well. Is where like the the stack depth mattered. Like there were tests in Ren to see how deep the stack depth was. And like you want to just have that as a constant in your language. You don't want that to be arbitrarily determined by whatever architecture you're running on.
Yep.
And you can do that with an iterative loop rather than using the C stack or the languages stack. Okay.
Okay, so we write like print, like a toString.
Sure. Or we'll let Copilot do it, of course.
Whoa. It wrote a whole eval loop.
I can't see it yet. It hasn't come through.
we'll do that later. We'll see what Copilot thinks our eval loop should be. Its hypothesis for print was a little bit not as ambitious.
Sorry, I was just slightly distracted.
We write eval. We will write eval. What is TCE? We'll get to eval.
Where are you?
I was just responding to William's comment asking about eval. We'll get to eval. This is just the sort of normal structure we use, which is like, what is the dumbest version of a Lisp interpreter? Well, one that doesn't interpret. But we'll get smarter. Okay, we want to print value. So we want to like match.
Yeah, I just think that nibbling at problems like we're doing is at least really important for me. It's how I think about doing coding.
Oh, tail call elimination. Yeah, we should be able to do that.
I don't know what that means.
We'll get there. Like that's way ahead of where we are.
Okay.
Print the symbol. Print null. Right. Printing the cell. Print left. Print right. This is not quite what we want. We want to.
Right, no, it's like, okay, so when do you? So I think when do you print? Whoa, hello.
I think there's going to be two modes for printing.
This.
Yeah.
And then I know you print this when right is nil.
Right. So like in terms of the Wikipedia article we were looking at, so the Wikipedia article was showing you this dot format. There's like two moods. There's like printing a list. Right. So here we want to print a list and unroll a bunch of these values. So we want to say like print list this cell. And we have to go implement print list. Print list takes a cell.
It always feels weird to fight Copilot. Like, you know that it's wrong, but you also don't want to fight the stream. Like, part of me feels like, well, you want to kind of do it the Copilot way because then you want like Copilot to help you later. I really wonder what this is going to, positive or negative, what sort of effects it's going to have on programming. So there's a thing that I believe is well documented in linguistics, the effect on like pronunciation. When national broadcast TV happened. They really flattened pronunciation across countries. And I do wonder if things like Copilot will do the same thing.
Because they'll sort of like push you into patterns.
Yeah.
Yeah. Well, I feel like with the API design, like whenever I'm writing code with Copilot that has an API, I find that Copilot really it's like it keeps auto-completing things that don't match my API. And when I think about it, I think, oh, that's really a better API that Copilot is using. It's like, it's more what people would expect the API to be. And so then it influences me to make my API like that.
Yeah, I always feel very torn about that because like, I'm not always sure that it is better, but I also do feel pulled to like follow the stream of whatever the hell Copilot has in its, the other thing that Copilot does is it, and we see this actually inside Google, or I've seen this inside Google, that there's a lot of like, cross-language bleed inside Google. Like the style in which one language does something then influences the style that it's done in another language. And Copilot clearly is bleeding other languages into Dart when I type Dart code, because it often spits out Dart that maybe doesn't quite compile or like clearly isn't quite Dart. And I just wonder if it's going to do that as well. Or like whatever the most popular style, because mostly it's written in JavaScript, the JavaScript style will now bleed into the JavaScript style. Like you've talked about this before with like Rust, where like when you have a problem in C, you go and you write it in Rust. And then once you've written in Rust, you go back and write it in C, and you realize you wrote better C.
Oh, I've had a more complete experience in that, where I've written something in C++, then I've had to implement the same thing in Rust, and that forced me to like straighten out the lifetimes. Then I went back and looked at my C++ code and like, oh, these lifetimes are really a little confusing. Let me restructure it to match the Rust code because it really has a clear idea of what's going on.
But I fear that Copilot will.
That's true. We have to respect the AI, but we still have control of our lives.
Anyways, I fear that Copilot could have a similar power, but not necessarily positive effect. Right? That it will push us all towards using JSON for everything, or push us, like, I'm not saying it's bad, but like push us all towards using whatever pattern, which is necessarily a good pattern. It's just the pattern that Copilot happens to have in its brain. It's just the bias expansion.
That's true. Yeah, you have to be really careful with bias in these things because they're highly suggestive to the people using them.
Anyways, I took us off on a tangent, but print list, this makes sense. Let's see, mute first, bool, sum, left, yeah, first false. Okay, yeah. This is just whether we're doing a join or not. We could just build up the list and spam out the whole list, but like, okay.
Yeah, this is again, we're using recursion. We probably should be using a stack.
Yeah. But as we talked about before, premature optimization is the root of all email. Well, probably also all email, but I meant all evil. And so the recursive solution is very simple. So why not use it?
I think firmware is on GitHub. Like, go search GitHub for U-boot. You're gonna find a million copies of it. Like,
I think there is a lot of questions about Copilot, and
I do not find that it distracts me from my creativity or zaps my flow at all. Like, it does sometimes, like, it changes the sort of pace and tenor of writing code, because as Eric was saying, you end up where you're reviewing code. But at least for me, I do a ton of code review. I probably do more code review than I do code authoring. So it's actually quite a natural process for me, is to say, okay, here's some code that like a junior engineer wrote called Copilot. Let me provide my review feedback by editing it into shape, like this, right? Like if this was a code review, I would exactly leave these comments on the code review, like, oh, consider converting this to a stack. Like we might not do that in this particular review because of the project timelines or other constraints, but I think that's the review feedback I would leave, even if only to have that discussion.
So in support of Live in Extreme, it does actually distract me at certain times. It distracts me when I'm working on my like architectural doc. So a common pattern for me is that I'll write out like the MVP steps or whatever that I'm doing in my README while I'm working on something. And if I have to turn Copilot off for that because it makes all sorts of like sort of dumb suggestions while I'm trying to think through the problem. But it doesn't distract me when I'm actually trying to spam out the code, because as you said, you can just flip into review mode and then you're just like.
I feel, by the way, this is like in the time we've been doing this show, this is by far the biggest change that has happened in the industry is this thing coming around.
Well, it absolutely, like, good or bad, we cannot ignore it because it has done something unignorable.
I pay for it. I don't use it professionally, actually, because I think the IP situation is a little unclear. But for all my like personal projects, I use it.
Yep. I don't know what the status is. I actually don't know whether we're allowed to at Google, but I don't use it professionally either. But I think that's an unsettled question for businesses.
Yeah, absolutely, anytime.
Okay, so print list.
I think we should try it. I think like what could go wrong?
We're good here.
What's the worst that could happen?
So we want this to be. This is here. Okay, line, right? So we want parse. Line. 3 or something. I don't know what it is.
Just value, right? Value.
Okay, and then we want
let these.
Oh, sorry. But it's let, not var. Sorry, haven't done this in a while.
And print.
Yeah, but it needs to do the this. Yep.
We can borrow all these things.
What?
No, we don't need to do that. It's option. We can print an option value. It'll print out no. Oh, if it's an error. Yeah, you're right. Absolutely.
Well, it depends on how we want to handle the error, but yes, this is the.
I think
this is what Copilot was trying to tell us to do.
You're usually right. Okay. Okay.
William says it's possible.
Oops.
Did we already read this? Developer Zeitgeist already misses a lot of really useful stuff. The common example being FP and logic programming. Oh, I think that there's. I mean, this is, I think, generally true across the world. It's like that expression, the future is already here, just unevenly distributed or something like that. Like, this is totally true. There's all sorts of pockets of brilliance in the world that just the lagging majority haven't noticed yet. And often I find that's actually because it hasn't been, there's like a chewing step that has to happen to like make something that comes from the pure community. Like ML is going through this right now, where the ML research community has like figured out all sorts of crazy, interesting stuff, but it needs to be chewed and like explained like in a way that others can digest it.
Yeah, like somebody had to build the VS Code plugin, right? And what's really bringing it to my attention is not the research paper or like all that stuff. It's the fact that there's a plugin that I can install in the editor that I like that then does a thing, right? And so it's that like integration step or like productization.
I think this is for me the most interesting part of the industry to be in, where you're like, I don't want to be like super far into academia reading a lot of papers, but just close enough to where like interesting things are being done that you can explain it to the like rest of the world.
And sometimes, like if you want to think about Flutter, right? That's a lot of what we did with Flutter is we took a bunch of innovative ideas from the web world and we like showed the mobile people like, hey, here's what the web world has been up to. They invented this cool reactive UI paradigm, and the mobile world was like, whoa, that's awesome. We love it, right? That's not surprising because the JS community had chewed it and had figured it out.
Yep. Okay, so since I could talk about that for hours, I'm going to choose not to. And whoa, right is never read. Why not?
That seems bad. Oh, the left value.
Print list.
Okay, so that's clearly wrong. The right needs to be read. There are. Hold on, we got one more comment. Yeah. That's,
oh yeah.
We had Bob on the show. If you want to go see the interview with Bob.
Bob is such a gift.
Okay, we need to use right here somewhere. So we print out left, but we need to cell. We need to change cell at the end of this. We need to say like cell equals cell dot right. Somehow.
Oh.
Otherwise, you're just going to print out the same value over and over again.
I don't think you want. Really, you want the arg to be marked mutt? Expected reference found option value. Yeah, this is not what you want. You want.
What do I want?
Oh, I don't know if I can Rust anymore, but like you want option value.
Yep.
Current.
Yep.
Except is equal to cell, I think, right?
Equal to cell, right? I'll turn this into Rust for you just by applying the right rotation. Actually, you can just say some cell, and then current left, and then we made current right.
Yeah.
Yep.
Sorry, I have not written Rust since I last updated the compiler, which is when I gave up integrating the GC into I went on my spiritual journey to try and integrate the GC that we wrote into Ren that we wrote, and I never quite finished.
Maybe current.
Yep.
Maybe current. Let's current equals maybe current. And then if this is the first, blah blah blah, then match on value dot left. So recurse.
You mean current dot left?
Current dot left.
Or yeah, current dot left.
Otherwise, recurse on value of that. With the symbol, go print it out. Otherwise, go to current dot right.
This is already an at. You want that? I think. No. What do we do? Current is already an at or an ampersand, right? It's already a reference.
Okay.
Okay, I screwed this up. What expected option value found value? Oh, these need to be sum.
Oh. Well, this is just print. It's just print. Print.
Print current left.
Current left. Okay. Good.
Okay.
Oh, Copilot was wrong.
Yeah.
And then why is it mad here?
Expected option at cell got option value. Ampersand cell. Is a cell a value? No. Do you want this?
Right. This is the thing that always trips me up. So let's just write what we want this. We want this to be ampersand option value. And so what we need to do is we need
cell is a value.
We need value. We need to like rewrap this in a value. Value cell. So you still need to know how to program. And then we
especially when dealing with Rust.
We need to do the thing where we permute the like this is we gotta move the ampersand.
Yeah, option has all these. It's like as ref or whatever to like grab out the ref version of the option. But help me. Okay, so I'm getting confused with cell is.
We can just simplify this because we can take this argument as option cell value, and then we can just say current equals cell.
Should cell just be part of that? Like, should value cell just be left, right? Like, why does this need to be? Why is struct cell separate? Is this just like option value, and then this is dead?
We could. But I don't think that's gonna. Do you think that will help us?
I think I'm just confused by the fact that we have two things. Sorry, I'm undoing.
This one. Stop undoing.
Okay. All right.
Print this out.
Okay. You were saving us here. Started reading that episode, How I Discovered the Book. Yes. Bob is a true gem.
Is that right?
He's also just a super nice guy.
Okay. I think I did it all except is it mad about this last line?
Expected found option value. Okay, that's fine. Ampersand. Can't assign twice to maybe current. It's immutable. Okay, it needs to be mutt.
Mutt. More mutt.
Unused variable cell.
That's true. Figure out as a cell, and we print it. Okay.
If the value is a cell, oh, I see. We don't need to parse out the innards of it.
Yeah, just more convenient to hold the option value because that's the type that we like.
Let's try it. Oh, if we just do foo, whoa, that's wrong.
That's wrong. But
okay.
Try
plus 1, 2.
All kinds of wrong. Okay, that's good. But we're making progress. So let's see. I think the problem is all in our printer, by the way.
Who this knows? Makes me want to write unit tests.
Okay, let's write some unit tests.
which makes our printer not. It shouldn't print. It should return a string.
Okay, that's
right?
I totally agree.
I mean, it could also like write to a buffer.
Yeah, let's pass in a buffer.
Or what? They have a print has a thing. It's like a writer or something. Or am I mixing Python and all the languages? They mix together in my brain.
Like a thing called a string buffer in Rust.
I thought like print had like a writer. Rust print. Standard format. Yeah. Standard format takes a formatter or something like that.
Oh yeah, they have that pattern.
They have some pattern, yeah.
Mm-hmm.
Format self formatter. But I thought there was also a write F. Yeah.
Yeah. So what is F? F is a formatter.
Is a formatter. Rust formatter. Oh, whoa. Comes from debug and display.
Yeah.
I think we're like too deep in the like trying to make it rusty here.
I think that's the right way of doing it rusty, but I think let's just do something dumber.
Oh, do we want to just implement this? Display for, wow, it's all coming back to me.
Sure, let's implement display. Why not?
All coming back. People who have been around me in person know that I sing stupid songs all the time. Maybe I do that on the show too. I don't know.
Oh, a little bit. We'll get a copyright strike, depending on how bad you are.
You think my renditions are close enough for a copyright strike? That feels like a challenge.
All right, you want to paste
7 seconds, but go ahead.
Oh, you do get 7 seconds. Do you want to paste that sample code you had? Okay, so we want to do this for option value, right?
Oh, can you do that?
Yeah, why not? It's going to be amazing.
It's going to be amazing. I believe. I want to believe.
And then I think we can also do it for cell value cell.
We're going a little deep here with 10 minutes to spare, but
all right, whatever.
I want to believe. Oh, you gave up?
I gave up.
I discouraged you. Anyways, I kind of just want a string. Is there like a string buffer, as you said? String buffer in Rust. The string native type. It's designed to be mutable and grow easily. Fine.
Okay, fine. We'll just do it that way.
Yeah, let's pass a mut string.
A mut string. We can do it. Well, let's unwind what we've done here.
It's not like Mariah Carey. No.
Oh, see, you have a fan with a lovely singing voice. It's a very nice compliment.
Thank you. All those years of voice lessons, worth it. Oh, it's Celine Dion. There we go. Our Canadian friends.
So how does this work? I say push.
Yes.
Push stir.
Push stir.
And I can just say symbol, right? For push stir nil. And then print list. Gonna pass my buffer. All right. This is.
You're gonna need to push stir with us. Whatever. It's all good. All great. Keep it up.
Push stir. Okay.
I'm reminded of our conversation pre-show. I did some like one of those like Myers-Briggs, like leadership-y things or whatever. I got my like 5 values or whatever.
Okay.
One of them was like being an encourager or something. So here I am.
One of them was recording artist.
It's clearly. That's my second career if this programming thing doesn't work out.
Okay, so I think I converted it to this to make it more testable. And then I do this.
Buffer mut string. Okay. Okay.
Now we're set up for testing.
Okay, so now I gotta help me remember how to test. It's like at test or something. Oh, at config test. Whoa, go Copilot. You got this.
It's totally wrong. It's hashtag, I think. And say mod.
But it knew what I wanted.
It knew what I wanted. And then you say like
that's right.
Hashtag test. Yeah, FN basic test. Excellent. Okay.
Yeah, like maybe Copilot only works for those of us, well, for people like me who are hobby programmers, right? And switch between 8 languages.
Just do A, B, and C, just for the sake of our sanity's sake. It's like a simple one. Okay. And then we need to say let string, but string.
Even string new.
Okay. Print. Okay. And then we'll say I want EQ.
Is it print's a reserved word, isn't it? It's sad.
Oh, we need to say use super. Use superstar.
I still think it's okay. Well, I guess we've stomped on their print word.
All right, we can say print value. Print value.
Sure. Okay. Okay. Sold. Okay.
All right. Well, let's try running the tests. It's totally should fail.
Cargo test. Yeah, it should fail.
Did you all know about Carbon for the public? Yeah, I've been talking with the Carbon team for many years. Turns out it's a lot of work to do what they did.
I had never talked to the team, but I do live really close to one of the engineers, so I was aware of its existence.
Okay.
Whoa.
All right. So it's something's very wrong, but it's okay. So let's try to make this test pass. Can we make a commit? Like I think this is because I kind of think we're gonna mess it up from here.
Okay.
Failing test. Perfect time to make a commit.
What is this? This is RDA 111?
Something like that. I'm glad we didn't promise to do eval in this episode.
We do tend to overpromise a little.
Okay. So what I'm curious about, can we look at this in the debugger? Because I'm curious whether our value is wrong or whether our printing is wrong. And I think the debugger will be a good way of distinguishing between those two cases.
Okay. Trivially done. Where do you want to break? Like break here?
Sure.
Okay.
So what is value at this point?
All right. What is this even? Like, okay.
I think you can collapse some of these, yeah. Collapse your call stack.
Okay.
Okay.
So value, left val and right val? What?
All right. Maybe the debugger was not that useful. Never mind.
I just don't understand why the Rust debugger is having so much trouble. Maybe I don't have like the right debugger or something installed, or
yeah, I don't know. Maybe it's not interpreting these types. Like,
okay.
Oh well. It was a dream.
It was a dream. But we can inspect it here, right? We can print value.left. Whether the unwrap is necessary, but sure. Why is it sad in life? It needs this.
So I have another idea here. So what I want to do is I just want to remove the recursion. So I want to like simplify our print function to see whether that's where the problem is.
Okay. Well, we're getting to the, like, it's almost like we're recursing in the wrong order, right? Because we're doing a depth first search, right? When we want, we're getting to the leaf first and printing the leaf and then coming back.
I have an idea. What if we log during the parsing to try to see what structure we're getting?
We can also probably just walk through some of this in our mind here. Okay, all right. So if we go to parsing token, we hit a left. We're making a new sub values.
Mm-hmm.
We get our next token. What is this from? Tokens. I see. We split white space. Okay.
Mm-hmm.
Otherwise, we push the sub values. Why do we push the sub values there? Oh, we first parse the innards and then push
Mm-hmm.
the result of that. Why?
There could be like an inner list.
I see. Okay. So does that mean we return? So like, okay, so now we're passed in just A. It's got neither of these. We don't match either of these. Otherwise, we push it to values.
Yeah, this doesn't seem right, does it?
And then we return it back from it?
No, this is totally wrong. we were seduced by Copilot.
Often the case.
So this passed code review, but needed tests.
What? Like this?
Okay, so let's write a simpler test,
case, isn't it?
Let's write a simple test. So so this is like a parse and print. Parse. Right.
I feel like this is a PSA, and that, children, is why you shouldn't use Copilot.
No, I think it's fine. Like this is. It's need to actually review the code. Let's just do a parse test, right? Let's parse just A. Okay. Now we should be able to assert exactly what we get, right?
We also could write some very dumb tests here, right? Like an error test. This, like A as well, should error.
I don't think that should error. But that's a good test case. This should not error. This should be a value. Let's unwrap this, and then we should say, right, this is what it should be. Some value.
That is not what it will do today, because right now it calls into the like from list.
Okay, but this is what it should do. Okay.
When should it come back with none?
So then let's parse parens A, for example. Mm-hmm. So this should be a value cell. This should be like a value cell new, like a symbol.
An A in a list, and a nil rather.
Let a symbol equal that, right? So this should be a symbol. Okay. And this should be none.
Which is empty, is cell empty or whatever, or value empty, but yeah.
Why is this bad? I
don't know, the Rust analyzer barfed. Hold on.
Value doesn't implement debug. Okay, we'll just show debug on everything.
Cell doesn't implement debug. Oh, that might have been part of the reason why the
we didn't have good debugging, so we didn't implement debug.
We didn't implement debug.
That sounds good. What else? Copy applied.
Expected enum option value found at value.
Okay.
This is a symbol. This is wrong. You want this to be
We just need to derive
unwrap.
Partial EQ.
Expected item after attributes. Expected option value found value. Oh, why is this think it's option value? Oh, fine. This doesn't need to be some. Okay. Expected value found at value.
What do we have to unwrap? We shouldn't have to unwrap. Oh, this should be sum. Why is this not sum?
Oh, well, this one unwraps. And yet it still comes back as option?
Right, because this can return an error.
Oh, it's different unwrap. Should we just unwrap it twice?
No, we should just keep this as sum.
Okay. Well, I removed this one from sum.
Okay, let's put the sum back in. Okay, so let's try this test.
Nope. Box cell and enum value. This is supposed to be box new?
Oh, no, this thing returns value. This is fine. We don't need any of this value stuff. Cell new does all this for us.
Okay. All right, so let's try testing this. It is actually really nice to be writing Rust again.
I bet writing a debugger is pretty easy once you have an interpreter. So writing a debugger is a lot of work.
Panicked at assertion failed. Left equals right. Left, sum cell, left, sum, symbol A, right, none.
Yeah, so
right.
our parser is wrong.
Yeah.
Let's go work on our parser.
But we knew that.
I know, but now we have a test.
This case is this case is wrong.
Mm-hmm.
Right? Every time we do anything, we turn it into a from vec.
Okay, that can't possibly be right. So
this is the like recursion case. Also, by the way, can we go back to this? It's not clear to me this is what we want. Like you may want an outer parse. Do you want the same thing that can parse this to be the thing that can parse this?
I don't know.
It's not clear to me that the thing that parses just a raw value, like
it's very Lispy what we've done here, because like you can have a syntax tree that's just a symbol. That's totally fine.
That is okay in Lisp. Okay.
Yeah, that's totally fine.
I didn't know if like JSON doesn't let you do that, right? Like you can't just have a string in a JSON file.
Yeah, and like other languages differentiate between like statements and expressions.
And Lisp
is totally expression oriented.
All right, great.
Okay, so our parser is totally wrong, so that's fine. Let's try to write. Let's try to actually write the parser that's correct.
All right, so, I do want to say we're 5 minutes over time.
Okay, I feel like we can maybe do it. So let's try to do it with a stack, because I want to have a stack. And I have my let's try this. So I pull my token out. As a token, then I'm going to create sub values. Okay, that makes sense.
Do we want like a split of parse symbol and parse list kind of thing here?
Maybe that could be an important thing. Let's just think about this. Okay, so I pull the next token. If the token is thing, that's fine. If it's not this thing,
you want to close your current list with this.
Right. But this case is wrong. I don't want to parse the token. Right? I've already tokenized it. So I want to like
yeah, you're right. That's definitely wrong.
I just want to push the token. Right? But there's like, what do I do if the token is a left parenthesis? I need to like recurse on this whole thing. So I think I don't want an inner loop is what's going on here. What I want to do here is I want to
have a count of open parentheses.
Right. I want to say stack push and vec new. Okay. And then I want to just continue. Right.
Yep.
Okay. And then if I get this thing, now I want to say let values equals stack dot pop.
Yep, and then you want this, the cell from Vec.
Right, so I need to match this, and if this is none, then return the error. Okay. Otherwise, if I get some values, I just need to say match pop. Otherwise, I get some values out, and then I want to. No, I want to on stack dot top. I want to push. I want to push this thing. This isn't quite right yet.
No, we have two. You need two things. Not just one stack. Right, you need your tree.
This is like a vec of option value is what I was thinking.
Okay. But I see, from vec takes option value. Okay, fine, sure.
So I pop the thing off a stack. I make my value. Let my value equals that. Okay. Now I need to see, does the stack have a top? I need to like match stack dot top. Okay. If it's some, then push the value. Otherwise, if it's none, I just return the value. Right, I'm done. Oh no, this is an error. No, it's fine. I return the value. If the last token of the input is right parentheses, that's legit. I just return.
Is continue what you want? I see continue continues this while. This can just break.
That can just break.
And anything else, we push this on the.
Yeah, if it's just a token,
on stack.top.push.
Yeah, it's the same thing. Or it's we make this a little subfunction if we want. Let value equals this, and then we either put it on top of the stack or we return it if the stack is done. Why is it mad about return?
It needs to be okay.
Oh, okay.
Comparison operators cannot be chained.
Turbofish. What more turbofish?
Turbofish. Yeah, heck new. That's what we want. Okay, mismatch types. Expected Rust option value, readline error, and found unit type.
It's saying not all control paths return.
Oh.
What do you need to say? Return. Well, we have to say, what is the empty string? The empty string, I think it's just going to be none. Like, okay, none.
Okay.
Our test.
Now method found top.
Oh, vec doesn't have a top? First?
Last. Yep, same thing. Can't borrow is mutable. It's mut top. Top mut. Stop mut. I bet it's the last mut.
Or mutts. Mutts in the right place.
To quote you, insufficient Vespian mutts.
Insufficient Vespian mutts.
Okay, shall we try and run our test of great justice here?
Yeah.
Failed.
Okay,
we had our left some symbol A.
Okay.
So our left was our goal.
We got a cell.
Oh, this is what we parsed too. What? This is main 149. So this one, sorry. So the left one we parsed was some symbol A. We might have failed the other one too. I don't know. Oh, we just parsed as a symbol instead of getting.
Oh, okay. That? Oh, no.
Oh, I know.
Mm-hmm.
It's because our parser expects this.
Oh, okay. Yeah.
Which we can debate whether that's correct or not, but like.
Oh, yeah, I think that's a good. Well, here, let's do this one.
Do test. A.
Yep.
Without spaces.
Mm-hmm.
Or A. Right.
Yep.
I bet we fail both of those. Okay. Let's try it again. I could do this all night, but we are going to eventually have to call it. Left was a none. Which one is this for? 149. So this one, we got into this. We pushed it onto the stack. Then we got...
We should pop the stack. We should have gotten something. This should have been none, and we should have returned it.
Well, in what path do we ever return none anyways?
Out the bottom here.
So that means we failed to get a next token?
Oh, that should always happen, right? Like what top?
Well, when you run out of tokens, it doesn't. But so when we get the first one, it's going to be this. And then we're going to get the A. And then we should get this.
Mm-hmm. This isn't quite right, but I think we're out of time on the show, which is fine.
Yeah. All right.
But we're close. Maybe we'll do it, clean it up in Easy Bake Oven, and maybe we'll come back next week and make more progress. But we're close.
We are. We have made significant progress. Anyways, this was fun. I enjoy writing Rust. I enjoy writing parsers. But it was good to see you.
Yeah.
We had a bunch of comments actually before we. We just did one last one that we didn't. Any thoughts on the C++ 20 modules? I know nothing about it.
Our toolchain team is super excited about them. I have not studied them yet.
Cool. Anyways, wonderful. Yeah. Oh, sorry.
No, go ahead.
I was just saying, wonderful to see you all you folks, and we'll see you next week.
Yeah, see you next week.